Day 132, Honors Physics, Electrostatics, problem number 40. And we're mixing it up here a little bit. This is back to a Coulomb's law problem. It's force. We're looking for force, not field. Well, part B is a field, but right now we're looking for a force on the lower left-hand corner, the negative 40 microcoulomb charge, given the dimensions of this triangle. So I'm going to use the diagram that's given here. And bottom line is, so now each of the pair of particles exerts forces on each other. I'm going to start with the bottom leg here, is that this guy and this guy are attracting each other. So how do you show that these two guys are attracting each other? They're exerting a force on each other, equal and opposite. Well, they're attracting because they're opposites, so there would be a force this way and a force that way. And we can call it F sub 1 and F sub 2. I'm most interested in F sub 1, but they're both the same size. You can figure out F sub 1, and that's Coulomb's law. It's K. It's 9 times 10 to the 9th. Times charge number 1, 40 micro, times charge number 2, 80 micro, divided by the distance, 0.40 squared. I'll let you figure out F sub 1. All right, that's a pair. They're both equal. And that's also F sub 2, but I don't really care about F sub 2 at this point. Anyways, now we look at another pair. On the left-hand side over here, I'll use blue. So the plus 20 at the top and the negative 40 also attract each other. So I can show that with vector arrows. They both attract each other. I can call that F sub 3 and F sub 4. And they're equal to each other. I really only care about F sub 3. And if I do that, I'll do it in blue. F sub 3, so 3, equals 9 times 10 to the 9th, times 40 microcoulombs, times 20 microcoulombs, divided by how far apart they are, 30 centimeters, squared. That's F sub 3. Now, once you have that figured out, you're almost done. We have to find the net force on that negative 40 in the corner there, because we don't really need to figure out the net force for the other two at all. We don't need to figure out the third pair, the repelling force of the 20 and the 80. It would look like this, but you don't need it. It would be difficult to do. You'd have an F5 and an F6. We don't need to figure those out. Actually, they'd be weak forces because they're so far apart, or farther apart than the other charges involved. But we're not going to figure out those two forces. All we need to worry about is F1 and F3. We got to combine them as vectors, and it's kind of nice because F1 is to the right and F3 is straight up. So if I draw my vector diagram up here on the right, I have F sub 1 this way. You'll have a number for that one, F sub 1. And then you have your F sub 2. No, F sub 3. Those are the two forces acting on my negative 40 microcoulomb charge. We're looking for the net force. It's nice because these are already their own components. So the net force will be this. I can call it F sub net, F net. I'll just call it R. That's my final answer. So you'll calculate R. And you can do that by Pythagorean theorem. Show you work for that. Pythagorean theorem or sines and cosines. But you also need to figure out this angle theta right here, because it says in part A to find the magnitude and direction of R, the resulting net force on that lower left-hand corner negative 40 microcoulomb charge. But anyways, show your work to figure that out with that diagram that I have drawn up here on the right. And then you have it.